Hello everyone, welcome to this lecture on CSMAR database and how to use it in academic writing. In this lecture, we are going to cover the following two parts. Part 1 is a general introduction to CSMAR, and in Part 2, we will discuss how to apply CSMAR data to academic writing through some example research articles with a special focus on the rise of AI and its impact on empirical research. And now let's get started with Part 1. So what is CSMAR exactly? It is short for China Stock Market and Accounting Research Database, a database for academic use with a structure of world-renowned databases such as CompuStat, and a focus on socio-economic development in China, a database of China designed by Chinese institutes and scholars, and is most suitable for telling China's story. CSMAR includes over 200 sub-databases with over 60,000 indicators, so as to cover as many research fields as possible in economics and management. And CSMAR has categorized all the sub-databases into 19 series, the name of which implies the pertinent research field, including stock market analysis, corporate analysis, market information, macroeconomy, industrial economy, etc. As for the qualification of CSMAR in terms of academic use, we have presently 13 sub-databases available on Words, and over 170,000 journal articles citing CSMAR as data source. Among all these articles, over 400 are published in top journals and counting. And for data searching and downloading, CSMAR has the following two functions: data query, that is, to search and download data from the website, and data service, including API interface to several statistical software for users to access data in Stata, R, MATLAB, and Python. For detailed instruction on how to use CSMAR for data search and download or other services, please visit our homepage and get the database manual and instruction video from our support center. Also, as CSMAR now has 13 sub-databases available on Words, for Words users, you can log in your Words account and find data vendors on its homepage under Data. Then we can see CSMAR in the vendor list and the 13 Words subscribed databases listed on CSMAR's homepage. So while you are using Words, you can also download CSMAR data. Now, building on the basic understanding of CSMAR, in the next part, we are going to talk about applying CSMAR data to academic writing. Among all of CSMAR data's series, this slide highlights the most frequently used and important ones, with an introduction to the content and list of featured sub-databases of each. China Listed Firm Research Series, for instance, provides comprehensive data on China-listed firms, including both the basic information such as financial statements and governance structure, etc., and the latest research hotspots in corporate governance, such as D&O insurance. Data from this series provide insight on in-depth analysis of China-listed firms. China Economic Research Series provides data on significant socio-economic topics of China, including the overall and regional economic development, new quality productive forces, digital economy, carbon neutrality, aging population, etc. And data from this series is very helpful for overall study of economic and social development and the policy making in China. Monographic study series also provides data on important research topics such as the Belt and Road Initiative, which is the cornerstone of China's regional cooperation. An authoritative and complete data set on this subject is of great value to relevant studies. For researchers in the field of finance, China's stock market series provides data on China's stock market, facilitating the study of China's ever-growing capital market. And Factor research series provides calculated indicators for financial studies, such as the skewness of the negative stock return and the down-up volatility ratio, capturing the stock price crash risk that can be found in behavioral finance, or liquidity indicators of stock market in stock liquidity. And to study environmental economic related topics, we can look into Green Economy series with subdatabases covering resource, environment, global warming, and green finance. In an international attempt to achieve carbon neutrality in time, it is critical to get relevant data on China, one of the major carbon markets, for comprehensive analysis. And China Industry Research Series provides data on various industries, including energy, new energy, pharmaceutical, communications, etc. And Partner Series provides datasets that are co-developed by CSMAR and other renowned research institutes. Databases include Firm Digital Transformation and Firm Carbon Disclosure Index. And how can all this data serve empirical research? We first map out topics from several major research fields, including corporate finance, and macroeconomics, with a list of related CSMAR databases and references as a general foundation. In corporate finance, for example, studies mainly focus on topics such as corporate governance, financing constraints, internal controls, enterprise innovation, etc., and the list of related CSMAR databases for this field narrows down the search range for users. For instance, in a study of corporate innovation, we can get data on patent or R&D from listed firms' R&D and innovation, common field level control variables from financial indicators, corporate governance, shareholders, etc., and for potential impact factors such as the digital transformation, we have the subdatabase called Digital Transformation, providing data on digital transformation process of listed firms. Or if we want to study the innovation effect along the supply chain, we can get relevant indicators from the subdatabase Supply Chain Research. As for the references list, it includes several top journal articles as example in case we need some references for our own study design. The same goes for the following two fields, finance and macroeconomics. So information from this table can assist you in locating research topics and relevant data sources. However, in order to make breakthroughs and valuable contribution to those major research fields in our own study, we also need to keep up with research fronts and find out what the latest research topics are. And here we draw references from the report 2024 Research Fronts published by Chinese Academy of Sciences. According to the report, in economics and management and other social sciences, the prominent trends of last year are the intersection and integration of digital and intelligent technologies with economics, psychology, and other social sciences, human health, climate, and environmental themes. So these three trends provide insights on choosing new perspectives or new variables for potential breakthroughs in our own study. Below are the top-ranking top research fronts of the year 2024, according to the reports. The hot research topics include evaluation of policy changes, and research on the impact of specific events, impact of COVID-19 on mental health of different demographics, climate change and investment decision making, the impact of anthropogenic activities on climate change, biodiversity, etc. Research on the relationship between social structural factors and health differences. Application of EEG data analysis in neuroscience, psychology, and cognitive science, deep learning algorithms, and financial forecasting, asset pricing, the problem of ultra processed food consumption, algorithms, human resources, and platform management for the gig economy, code of ethics for artificial intelligence, and the list of hot research topics can also shed light on potential breakthroughs for our own studies. And as we are now in the age of AI, with the intelligent technologies as one of the most prominent trends, we will select a few example articles to exemplify how to incorporate this trend into our study with the help of CSMAR data. Existing studies usually approach the impact of AI from two different ways. The first one is to capture the AI trend by measuring the development of AI. AI development is usually measured on two levels, firm level and macro level. On firm level, the three most common proxies for AI developments are AI keywords, AI investment, and AI innovation. The variable AI keywords is the frequency of AI-related words such as artificial intelligence, computer vision, cloud computing, etc. in listed firms' annual reports, counted by text analysis method, and data for which can be found in CSMAR Artificial Intelligence Research Database on the AI level of listed companies. An AI investment is firms' investment in AI-related software and hardware, data for which can also be found in this subdatabase Artificial Intelligence Research Database from CSMAR. On the AI level of listed companies, AI innovation is the number of AI patents applied for by a firm. The identification of AI patents is based on the International Patent Classification, IPC, or text analysis of patent documents. On macro level, the most common proxies for AI development in existing studies are regional AI development, regional AI investment, and robot adoption or exposure. Regional AI development is the number of AI companies in each city. In CSMAR Artificial Intelligence Research Database, we have sorted out the list of AI companies and their basic information to be found on the Artificial Intelligence Enterprise. Regional AI investment is the investment in information transmission, software, and information technology service industry, data for which can be found in CSMAR Macroeconomic Database from China Economic Research Series. And robot adoption or exposure is calculated with equation as such. Data required for the calculation include the employment rate and robot installation of given industry. The employment data are provided by CSMAR Macroeconomic Database, and robot installation data can also be found in CSMAR Artificial Intelligence Research Database under Statistics on Industrial Robots. And to further elaborate on how to conduct research regarding AI trend, we select the following journal articles as examples. Our example will cover all three major research fields as we mentioned before, corporate finance, finance and macroeconomics, and include other important prominent research trends besides AI. Also, we will have the examples that exemplify the use of different measurements, all these different measurements of AI development as variable. So we have the first example here studies how AI adoption affects labor income share. AI's impact on labor market has been controversial. The adoption of AI either replaces some workers or enhances human capabilities so that workers can perform higher value work with better productivity. And this study conducts empirical analysis to examine the real impact. Dependent variable of this study is labor income share, measured by the ratio of cash paid to employees to total revenues. Relevant data can be found in the subdatabase financial statements. The key independent variable is AI adoption intensity, measured by AI-related keywords frequency in annual reports. Relevant data can be found in the subdatabase artificial intelligence. And the alternative measure is the number of AI-related patents held by the firm. The findings of this study show that the AI implementation positively influences labor income due to the improvement of innovation capacity and technology upgrading. For the mechanism analysis, the data for firms' R&D expenditure and the number of granted patents are required and can be found in the subdatabase listed firms' R&D innovation. The next example studies the effects of digital investment, specialized investment, and their synergy on firms' digital competitiveness. AI is a branch of digital technologies, so the analysis of digital technologies can be extended to AI-related topics as well. And the focus of this study is SRDI firms, which means medium-sized to moderately scaled businesses known for their specialized refinement, differentiation, and innovation. And such firms usually have limited resources, and only moderate amount of digital and specialized investment can boost their digital competitive advantage. Excessive investment will burden the firms and compromise their advantages. The digital competitive advantage is measured by index system covering the value, scarcity, unimitability, and irreplaceability of digital patents, data for which can be found in INCOPAT, a global patent database. The key independent variables include digital investment, specialized investment, and the synergy, which means the coupling coordination degree of two types of investment. Digital investment is measured by the ratio of digital investment to operating income, and using digital investment amount instead of the keyword frequency of digital technologies can avoid overestimation and reflect the real investment level. So data for digital investment can be found in the subdatabase firms digital transformation for study of AI-related investment. Data are available in the subdatabase artificial intelligence. The results prove that the appropriate level of digital investment or specialized investment can enhance firms' digital competitive advantages, while excessive investment has counter effects. The synergy between the two types of investment can boost digital competitive advantages. Now, the third example studies the impact of regional AI development on the quality of corporate environmental information disclosure. Environmental information disclosure is a crucial mechanism for firms to fulfill their environmental responsibilities, respond to stakeholder concerns, and enhanced transparency. With the development of AI, the environmental regulatory process can be improved by AI-empowered data collection, information processing, and automated disclosure. Dependent variable of this study is the quality of corporate environmental information disclosure measured with an index system including environmental management, environmental performance, and governance, environmental investment of sample firms. Data for the index system are available in the subdatabase Environmental Research. The key independent variable is regional AI development, measured by the number of AI companies in each city, and data for which are available in artificial intelligence. And the study replaces the independent variable with industrial robot adoption in robustness test, data for which are also available in artificial intelligence. The findings indicate that regional AI development significantly enhances the quality of corporate environmental information disclosure. Our fourth example studies the impact of artificial intelligence on financial risk. AI technologies can increase firms' productivity, information transparency, and decision making efficiency so as to effectively reduce financial risk. So, dependent variable of this study is financial risk, measured by the annual standard deviation of stock prices, data for which are available in the subdatabase stock trading. The key independent variable is corporate artificial intelligence, measured by the frequency of AI-related keywords in annual reports, and data for which are available in artificial intelligence. The results of this study show that artificial intelligence can significantly reduce corporate financial risk, mainly by alleviating corporate financing constraints and efficient investment. The fifth example here studies the impact of AI on financial labor markets. Some works in the financial sector, such as credit approval, are highly standardized and data-driven and are believed to be easily replaceable by AI. However, some scholars profess that in the long run, AI development will help create new positions as specialized technical talents are being trained accordingly. So, the dependent variable of this study is the employment and income levels of financial sector, measured by the number of employees and total wage bill of the financial industry, and data for which are available in the subdatabase macroeconomic. The key independent variable is AI development, measured by investment in information transmission, software, information technology services industry, and data for which are also available in macroeconomic. The results show that regional AI development considerably enhances employment and income levels in the financial sector. And the sixth example studies how AI development drives industry upgrade. AI can increase automation, reduce labor costs, optimize processes, and enhance product quality for traditional industries to boost their competitiveness and ability to move up the value chain. AI can also foster new business models such as smart manufacturing and intelligent healthcare to deepen the structural transformation, laying the foundation for industrial upgrades. The dependent variable of this study is industrial structure transformation and upgrading, measured by the ratio of tertiary industry value added to secondary industry value added, and data for which are available in the subdatabase macroeconomic. The key independent variable is AI development, measured by the number of artificial intelligence patents in a region. The findings indicate that AI development positively promotes the transformation and enhancement of industrial frameworks. The last two examples of this part focus on the impact of industrial robot adoption, and this one examines the impact of industrial robots on workplace safety in China. Industrial robots can improve workplace safety by performing dangerous tasks on behalf of workers and significantly enhance workplace safety. The dependent variable of this study is workplace safety, measured by workplace accident rate and fatality rate, data for which can be found in the subdatabase event study. The key independent variable is robot exposure. The calculation requires national stock of industrial robots and data for which can be found in the subdatabase artificial intelligence, and the employment share of industries, data for which can be found in macroeconomic. The results prove that the adoption of industrial robots can increase workplace safety. The next example examines the relationship between the adoption of industrial robots and environmental pollution. Industrial robots decreases pollution emissions by optimizing the energy consumption structure and enhancing energy efficiency, as well as enhancing pollution treatment capabilities and boosting green technological innovation. The dependent variable of this study is environmental pollution, measured by an index system including industrial waste discharge and PM 2.5 concentration, data for which can be found in the subdatabase global warming. The key independent variable is robot adoption. The calculation requires the national stock of industrial robots, data for which are available in artificial intelligence, and we also need the employment share of industries, data for which can be found in macroeconomic. The results prove that the adoption of industrial robots has a negative effect on environmental pollution. And this concludes the example on studies regarding AI trend. Other than capturing AI trend, existing studies also employ some AI tools as AI revolutionizing the research methods and tools for social sciences. Artificial intelligence has revolutionized the field of natural language process (NLP) in recent years with the development of powerful language models like BERT and ChatGPT. These models have enabled machines to understand, generate, and interact with human language in unprecedented ways, opening up new possibilities for businesses across various industries. And BERT, short for bidirectional encoder representations from transformers, is created by Google and can understand the context and meaning of words in a sentence, excels at tasks like sentiment analysis and question answering. ChatGPT is developed by OpenAI. It can generate human-like text, answer questions, and engage in conversations, and perform basic sentiment analysis on text data. Both models have been employed in empirical researches. We've also select a few example articles in this regard. The first example employs BERT model to measure investor sentiment of China's stock market. Traditionally, Investor sentiment was measured with various sentiment indicators, such as the Consumer Confidence Index or Volatility Index, and such indicators attempt to capture the mood of investors by tracking market data. With the development of technology, it then becomes increasingly popular to measure sentiment with textual analysis methods. However, as pointed out in this study, both sentiment indicators and textual analysis methods have their own flaws. For instance, they cannot process contextual information and therefore cannot capture sentiment accurately. Large language models, however, have exceptional contextual understanding capabilities and can capture the subtle nuances of sentiment in natural language effectively. Therefore, this study uses BERT model for sentiment analysis. Media news big data were used to train the Chinese financial large language model, that is, over 300,000 Weibo posts from authoritative financial media accounts. And empirical results show that the large model sentiment significantly outperforms the dictionary sentiment in both in-sample and out-of-sample predictive tests, and achieves better performance in asset allocation. The large language model sentiment variable can also predict macroeconomic variables and has stronger predictive power during extreme events and economic downside. Other than measuring investor sentiment, large language models are often used in capturing the tone manipulation in firms' MD&A. And the second example uses ChatGPT 3.5 and ChatGPT 4 to investigate tone manipulation in the management discussion and analysis of annual reports of Chinese listed companies. Both BERT and ChatGPT are employed in the process. The efficacy of ChatGPT largely depends on the writing of prompt, and in this study, to simplify the expression, the prompt is set as play a professional and cautious financial analyst. I will give you the contents of the annual report. Please express it more understandably. To generalize the tone, the prompt is set as play a professional and cautious financial analyst. I will give you the contents of annual report. Please rewrite the contents by replacing the emotional words with more common emotional expressions. And the results of this study verify the manipulative behavior of complex expressions and sentiment word substitutions. Large language models can also be used to analyze various sorts of text, such as environmental complaint text from China's e-government platform, and this example uses stacking BERT model to examine the hot topics and sentiment characteristics of these environmental complaints. Further studies on different types of text, such as consumers' complaints or online recruitment information, can refer to the same paradigm. And that is how AI tools can be used in empirical research. And that's all for this lecture. We sincerely hope it will help you better understand CSMAR database and its application to academic writing, especially in the age of AI. Thank you so much for your participation.